Okay, we've been talking about rates and ratios and unit rate and rate of change and different things like that. We're now ready to talk about a rate of change or a ratio that's extremely useful when we're talking about graphs. You're going to see a whole bunch of this. So we're going to introduce a new word here. So this is section 4.3, and the I can statement is I can find slope from triangles. S-L-O-P-E, slope from triangles. Now the warm up here, we are going to need a little bit of vocabulary here. So it says label the hypotenuse, that's how you say that word, the hypotenuse, the right angle vertex, the height, and the base. Okay, so we've got a triangle drawn off to the side here, and we want to label four things: the hypotenuse, the right angle vertex, the height, and the base. Now, a right angle and vertex, you should know what a right angle is. Remember, that's a 90-degree angle, and a vertex is a corner of a polygon or a figure or something like that. So the right angle vertex is right here. So the first thing I'm going to do is I'm going to put that right angle box, that indicator right there. Now, the height of the triangle on this particular one is right here, so I'm just going to label that as height. That's the vertical part of this right here, going from top to bottom. And then the base, now a lot of times we'll have the base down on the bottom since this doesn't really have a bottom. We're going to label the base right here. So this is the base and this is the height. And then we're going to label the hypotenuse. Now, if you've heard this word before, great. If not, it's pretty easy. It's a weird word, but it's a very easy definition. The hypotenuse is the side that's right across from the right angle. So this side over here is straight across from the right angle. So this is called the hypotenuse. Okay, weird word. Hypotenuse. So we've got the base, we've got the right angle right here, we've got the height labeled, and this right here, this side that's across from the right angle, that's called the hypotenuse. Now, a ratio that's really useful is a fraction that describes how steep a line is. So a ratio that's really useful is a fraction that describes how steep the line is. Remember, we talked about how we normally write ratios as fractions. We call this fraction the slope of a line. Okay, and one way we can find the slope of the line, one way we can find this fraction is by drawing a right angle using the line as the hypotenuse. So we're going to draw a right triangle using the line as the hypotenuse. Hypotenuse. So we'll spell that one more time, and then hopefully we don't have to do that for a while, but you do need to be aware of that word. So here's example one. I'm going to slide this down. Okay, keep that picture in mind right there. And it says, draw a right triangle using each dot as the right angle vertex and the line as a hypotenuse. Then find the slope of the line by writing the ratio of each triangle's height over its base. So we're going to put the height on the top and we're going to put the base on the bottom. And it says reduce each fraction as necessary. So you'll notice that I've got different colored dots right here. So what we want to do is we want to figure out what this slope fraction is. Okay, and it tells us we're going to do this by drawing a right triangle. So here's what I'm going to do. We've got these little dots that are right angles at each other. So I'm going to draw a vertical line right here, and I'm going to draw a horizontal line right here. Okay, that's our triangle. There's our little right angle right here, just like we had up above. Okay, kind of like that picture right there. And then we're going to figure out what the height is, and we're going to figure out what the base is. So we've got our height right here, matches up with that. We've got our base right here, and the hypotenuse is the line over here. So the only measurements that we're worried about is how far it is from top to bottom, this vertical distance, the height, and then we want to know what the base is. So let's go ahead and count, and let me make sure everybody knows how to count. We count spaces, we don't count dots. So from this point on the line to this point on the line, we're going to go from here up to here and then over to there. So what we want to do is we want to measure the slope. So we're going to do this. So for this height, we're going to go 1. We don't count this dot right here as 1. We're going to go 1, 2, 3, 4, 5, 6, 7. Okay, so the height on this is 7. So I'm going to write down height and base. And this is 7 for the height. So we went up 7. And then again, we're counting spaces. So don't count this one. 1, 2, 3, 4, 5, 6, 7. So the base is also 7. So I'm going to label that as 7. So we end up with, and we're going to reduce this, so we end up with 1. So according to that calculation, the slope here, the slope fraction is 1. Now I did reduce that. We could put 1 over 1 if we wanted to. We normally just write that as a 1. Now I'm going to change colors. I'm going to go with the blue one this time. So let's see. We're going to go up to here. There's the height. And over to here, there's the base. So let's count. 1, 2, 3, 4. So I'm going to put a 4 right here. and 1. Again, we're counting the spaces. That's one space. Don't go 1, 2, 3, 4, 5. There are 5 dots that make up that line, but there are only 4 spaces. Let's count them. 1, 2, 3, 4. And some people like putting the little marks there as they go through and count. That's totally fine. Either way, that's a 4. So we've got the height right here. We've got the base right there. So we've got 4 on the top and 4 on the bottom. So we end up with a 1. So according to that one, the slope of that line is 1. Okay, let's do this green one. So we're going to go straight up and straight over. So there's our right angle right here. So we're going to go up 1 and over 1. So this is up 1 unit. There's 1 space right there and 1 space right there. So this is going to be 1 over 1. So we end up with a 1. And then let's do the black one. This kind of overlaps here. So I'm going to go like this and like that. Put a little right angle in there so we can tell for sure. So from here, I'm going to go up 1, 2 spaces. So that's a 2. From here, we're going to go over 1, 2 spaces. So that's also a 2. So I get a 2 on the top and a 2 on the bottom. So I get a 1 there. So according to the calculations that we made on this one, the slope of that line, or the number that represents how steep it is, the fraction that represents how steep it is, all of these are the right fraction. They all just reduce to 1. Okay? Now, I do want to mention that we said height and base. What we're doing here is we're putting the vertical over the horizontal change every single time. So this is how much the vertical change, how much the y's change, if you want to think of it that way, over how much the horizontal changes, how much the x changes. Now there's some really good reasons for doing this, and you'll see that in the next couple of sections, but it's going to be much better if you keep track of the vertical change, whether we go up or down, and then whether we go right or left and how far. So that's what we're comparing here. So keep that in mind. All the problems today are very similar to what we're going to do on this set of notes. So I'm going to do the same thing on this one. So you'll notice that these are all lined up, which is not a problem. The instructions are the same as what they were on the previous one. So we're just going to do the same thing. I'm going to go through here and I'm going to do this. I'm going to draw a right triangle right there. And again, we're counting spaces. So this is 1 space and this is 2 spaces. So we're going to do the vertical over the horizontal. Okay, we can also say that's the height over the base. Always that height on the top, always that vertical part on the top. So we're going to put a 1 on the top and we're going to put a 2 on the bottom, and that happens to be reduced, so we're done. Okay, change colors here. I'm going to go to the next one. So this would be all the way up to there and all the way over to there. Okay, so let's count. 1, 2, 3. So I'll put a 3 right here. 1, 2, 3, 4, 5, 6. So that's a 6. So we're going to do the vertical, which is 3, over the horizontal part, which is 6. So we end up with 1/2. Okay, looking good so far. Going to do the next one. So I'm going to draw again a point, triangle straight from the line up to the point, and then all the way over to this other point. Notice how we end at some nice convenient points right here, so that's awesome. So we're going to go up 1, 2, 3, kind of confirms what we counted before, 4, 5. So this is going to be a 5. And let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be a 10. So again, it's the vertical part, the rise, or sorry, the height over the base. So this is going to be 5 over 10. Okay, it's this one over that one. So we also end up with 1/2. Okay, and then the last one, we're going to draw that triangle so it looks like this and this. And let's see what we've got here. Okay, if that was 5, then this would be 6. And if we count over here, if that was 10, we'd add 2 more, so this is going to be 12. And I'm just going to double check. 1, 2, 3, 4, 5, 6. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We go all the way to the end there. So it would be the vertical, which is 6, over the horizontal, which is 12, the height over the base. So we end up with 1/2 again. Okay? So that's the idea. Now, because this line is nice and straight, we should get the same slope every single time, but this exercise of going through and drawing these triangles is going to be really valuable, especially if you do it the way I taught you to. So we want to figure out whether we go up or down and then right or left. It's the vertical over the horizontal. Now, it says, would we get the same answer if we drew the triangle below the line? I normally have somebody say, well, hey, wait a minute. What if we did this below the line? So I'm going to change, and I'm going to do this back in red, and I'm just going to pick a couple of points right here. So I'm going to pick this point right here and this point right here on the line. Okay. Now, those are two really nice convenient points because you'll notice that there was a little kind of a little cross mark right there, a little dot right there, and a little dot right there. It matches up with that grid pattern right there. So if I were to draw a right triangle right here, it would look like this. Okay. Now let's go ahead and count. 1, 2, 3, 4. So this is 4, and let's count here. 1, 2. So this would be 2. This is the height, and this is the base. This is the vertical right here, and this is the horizontal right here. So let's go ahead and make the slope fraction. It was always the height over the base, the vertical over the horizontal. So let's put 2 over 4, and we end up with 1/2. We end up with exactly the same answer that we did for all the other ones. So the answer for this is yes. Now for these lines, it's just easier to get used to drawing the triangle above that line right there. And that's going to help us be ready for what's going to come in the next couple of sections. So I'm going to shrink this down, and we're going to take a look at the two of these lines right here. And what I'd like you to notice is the number that represents how steep this line is 1, and the number that represents how steep this line is just a 1/2. So the slopes we found in these examples above describe how steep the lines are, which we mentioned just a second ago in our intro for this, but now you can kind of see it. This number is 1, okay, so it's not a huge number, but it's bigger than this one. This is a smaller number, so it's not quite as steep, and that's kind of the way you can use slope to gauge how steep a line is. Kind of the bigger the number is, the steeper it is, and the smaller number it is, the smaller it is, or the less steep it is. Okay, that's what your assignment's going to be like. You're going to be drawing triangles, figuring out heights and bases, or how far you moved vertically, and put it over how far you moved horizontally and stuff like that. So again, if you've got any questions, please ask. Good luck with everything.